Greetings everyone! For today, we will be verifying identities in our video tutorial. Before anything else, we first have to recall the reciprocal identities. For our first identity, we have sin data is equal to 1 over cosecant data. Cos data is equal to 1 over secant data. Tangent data is equal to 1 over cotangent data. Secant data is equal to 1 over cos data. Cosecant data is equal to 1 over sin data, while cotangent data is equal to 1 over tangent data.
For the ratio identities, tan theta is equal to sin theta over cosine theta and cotangent theta is equal to cosine theta over sin theta. For the Pythagorean identities, 1 plus tan squared theta is equal to secant squared theta, cot squared theta plus 1 is equal to cosecant squared theta, and cosine squared theta plus sin squared theta is equal to 1.
You can manipulate these identities by transposing a term.
For the first example, we have 1 plus 2 sin theta cosine theta is equal to sin theta plus cosine theta squared. Let us rewrite sin theta plus cosine theta squared. For this equation, we will be using FOIL method. This will result in sin squared theta plus sin theta cosine theta plus cosine squared theta. Since sin squared theta plus cosine squared theta is Pythagorean identity, we will be substituting it in 1. Final answer is 1 plus 2 sin theta cos theta. For example number 2, sin theta over 1 minus cosine theta plus 1 minus cosine theta over sin theta is equal to 2 cosecant theta. First, we will be using the butterfly method to verify the left side, wherein we will get sin squared theta plus 1 minus 2 cos theta plus cos squared theta over 1 minus cos theta times sin theta. By using the Pythagorean identity, we can simplify sin squared theta plus cosine squared theta to 1. Therefore, we will have 1 plus 1 minus 2 cos theta over 1 minus cos theta times sin theta. Then, 2 minus 2 cos theta over 1 minus cos theta times sin theta. We can factor the numerator by 2 and get 2 times 1 minus cos theta over 1 minus cos theta times sin theta. We then cancel like terms and get 2 over sin theta. We now use reciprocal identity to get the answer. 2 over sin theta is equal to 2 cosecant theta. For example number 3, 1 plus cos theta over 1 minus cos theta minus 1 minus cos theta over 1 plus cos theta is equal to 4 cot theta cosecant theta. In this equation, we will be using butterfly method to verify the left side, wherein we will get 1 plus 2 cos theta plus cosine squared theta minus 1 minus 2 cos theta plus cos squared theta over 1 minus cos squared theta. Now we have to cancel like terms. This then will only leave us with 2 times 2 cos theta, in which can be rewritten as 4 cos theta, and 1 minus cos squared theta for our denominator. And this will be 4 cos theta over sin squared theta since we used Pythagorean identity. We can simplify the denominator sin theta using the reciprocal identity. Therefore, we can get 4 cot theta cosecant theta. For example number 4, secant to the 4th power theta minus tan to the 4th power theta is equal to 1 plus sin squared theta over cos squared theta. We verified the left side by using the difference of two squares, wherein we will get secant squared theta plus tan squared theta times secant squared theta minus tan squared theta. We then use reciprocal and ratio identities to get 1 over cosine squared theta plus sin squared theta over cosine squared theta times 1 over cosine squared theta minus sin squared theta over cos squared theta. We now simplify to get 1 plus sin squared theta over cos squared theta times 1 minus sin squared theta over cos squared theta. By using Pythagorean identity, we can simplify 1 minus sin squared theta to cos squared theta. We now have 1 plus sin squared theta over cos squared theta times cos squared theta over cos squared theta. We can cancel cos squared theta over cos squared theta since it is equal to 1. We now have the answer, which is 1 plus sine squared theta over cos squared theta.
For example number 5, tan cube beta plus cot cube beta is equals to secant squared beta plus cosecant squared beta minus 3 times tan beta plus cotangent beta. First, we will apply the Pythagorean identity to the right side and change secant squared beta plus cosecant squared beta minus 3 to 1 plus tan squared beta plus 1 plus cot squared beta minus 3. And then combine the like terms and it will become tan squared beta plus cot squared minus 1. Now, we can multiply it to tan beta plus cot beta. It will be tan cube plus tan beta cot squared beta minus tan plus tan squared beta cot beta plus cot cube beta minus cot beta. Then, we will transform tan beta, cot squared beta, and tan squared beta, cot beta into the ratio identities, which is tan beta is equals to sine beta over cos beta and cot beta is equals to cos beta over sine beta. We can cancel the numerator and denominator with the like terms. We will use ratio identities in this process, so tan beta will be sin beta over cos beta and cot beta will be cos beta over sine beta. So, tan cube beta plus cot cube minus tan beta plus cot cube beta minus cot beta cancel, and then combine like terms and it will become equals to tan cube beta plus cot cube beta.